All right, so for question number 4, we have to determine the absolute max and min of f on this interval. Remember this graph again, this is a graph of f. And we also determined earlier that is the same thing as g prime, okay, because g is the integral of f is equal to g, so the derivative of g is f. So to find the absolute maximum of f, we're looking at this graph. Okay, so what is the absolute maximum of this function? We have a lot of relative extreme on this graph. We have a relative mean here, a relative max here, a relative mean here, and a relative max here. So out of all your relative maximum, um, which is the absolute maximum, which is the biggest of all your maximums? So we have two relative max in this function. One, that interior max and that endpoint maximum, which is higher. This has a higher output, so our relative max is our absolute max. We have absolute maximum of f is at um, x equals 5, and the value is um, f of x equals 2. Okay. All right. How about our absolute mean? Absolute mean. We have two relative minimas in this function. Um, this is a relative mean right here, and that's a relative mean, which is the lowest out of these two. This clearly is your absolute minimum. So absolute minimum of f is at x equals 0, and the value is f of x equals -3. Okay, so there goes the absolute max and mean of the graph of f, or the function f. Now let's move on to problem number 5. We're to take a look at this function h, which is defined as, h of x equals the square root of g of x. If g of -4 is equal to 1, find the equation of the tangent line to h at x equals -4. Okay, so we have a new function here, a composite function, and we have to find the equation of the tangent line to that function at x equals -4. So to get started, let's write down an equation that will help us find the equation of the tangent line. We're going to use a really simple formula or equation, which is the point slope form of the equation of a line. So we have y minus y1 equals mx minus x1. Okay, so this equation basically tells you that you need um, uh, x1, y1, and a slope in order to write the equation of a line. Okay, so let's go ahead and find, how about we find x1, y1 first? Okay, what is the point that we're looking at? The point has to be on this function, h. We know that x1 is equal to the x coordinate of the point, which is -4. That means that y1 is going to be equal to f of negative. I'm sorry, we're not looking at f here. We're looking at h. So y1 is going to be h of -4. Okay? So what is h of -4? H of -4, we know that h of x is the square root of g of x. So h of -4 is going to be the square root of g of -4. So what is g of -4? We're told that it's equal to 1. So we're going to be looking at the square root of 1, which is equal to 1. All right? So we have the point. X1 is 4, -4, and y1 is 1. Okay, so to write down the equation of a line, you need y1, x1, and m. So we need to find m, okay? So m is basically the slope of the tangent line at the specified x value. So all we just need to find is, we need to find the derivative of, we have to find the derivative of the function, h prime, and evaluate it at the specified x value to get m. All right, so m is basically m at x is equal to -4 is the same thing as h prime of -4. The slope of a tangent line at x equals -4, that's what we're looking for. All right, so how do we go about finding this? We just have to find the derivative of the function first. H prime of x is uh, the square root of g of x prime. We need to find the derivative of that function because we are told that h of x is equal to root g of x. So h prime is simply going to be the derivative of the square root of g of x, okay? All right, so remember the differentiation rule. The derivative d dx of root x is simply 1 over 2 root x. In this case, we're going to be looking at actually d dx of root u because we have a composite function, so it's going to be 1 over 2 root u times u prime. In this case, u is simply g of x. All right? So this is for a non-composite function. This is the formula for a composite function, which is consistent with what we have here. If you do not want to use this formula, you can convert this into an exponent, u to the 1/2, and then do the same procedure. At the end, you end up with this expression. All right? Okay, so let's go ahead and do this. Differentiating using the chain rule. We're going to have 1 over 2 root u, 2 root u, but we know that u is the inner function, g of x. Let me put that in blue, in green, sorry, g of x, times the derivative of an inner function, g prime of x. Okay? All right, so this is the expression for our derivative. Doesn't look very pretty, but we're just going to evaluate this derivative at -4. Okay, so we're going to have 1 over 2 root g of -4 times g prime of -4. Okay, so we're going to have 1 over 2 g of -4. I think we already worked that out before. G of -4 is what you get when you plug in -4 into G, and we're told that, remember we were told earlier that G of -4, where is it, is 1, so that's what we're using. We already used it before, so 1 over 2 root 1 times G prime of -4. Now what is G prime of -4? What is G prime? Remember we stated earlier that this function is the antiderivative of f, which is g. So this function is f. F is equal to g prime. Okay? So g prime at 4 is the same thing as f of 4. Okay? We did this earlier. Where did we do it? Yes, in problem 2, when we're doing problem 2, remember we said that g prime is f of x. So let's go ahead and write that down. So since g prime is f of x, g prime of 4 is going to be f of -4. Okay? Since g prime of x is equal to f of x. Alright? This is an antiderivative of g, so the derivative of g is going to be f. Alright, now f of -4 is what you get when you evaluate this function at -4. So f of -4, if you look here, for this function, if you go down 1, you go over 2 units, right? So if we go down half of that, which is 0.5, then we're going to go over 1 unit right here. Okay? So let's find out what the output is. So we just trace it, f of -4. Can you see where it's going to be at? So if I trace -4 to my function, and I trace it out, it's going to be right at the center. Okay, remember the slope of this line is -1 over 2. So if you go down 1 over 2, if you go down 1/2, you go over 1. Okay, so if you go down 1/2 from 1, this value right here is going to be 1/2. Okay, so this is 1/2 right at the center. And that's what f of -4 is going to be. So this is going to be, square root of 1 is just 1. 1 over 2 times f of -4, which is 1/2. And that equals 1/4. Okay, so that's the value of our slope, which is m. Now let's rewrite the point slope form of the equation of a line again. Remember, it's y minus y1 equals m x minus x1. Now we're going to put together everything we have. Y minus y1, y1 was 1, equals the slope of 1/4 times x minus x1. x1 is -4, so if you multiply that with minus, it becomes +4. So if we distribute 1/4 to these two terms, we have 1/4x plus 1 plus 1. If you add this one to the other side, which gives us the equation y equals 1/4x plus 2 as the equation of the tangent line. So this is the equation. Y equals 1/4x plus 2 is the equation of the tangent line, um, tangent line to h of x at x equals, what was the x value again? X equals -4. All right, so there goes your final answer.